Hello and welcome to SETI Live. I'm your host, Beth Johnson, Communication Specialist here at the SETI Institute. Welcome into all of our viewers from around the world. Thank you for joining us. Please let us know where you are watching from. And welcome into listeners on the podcast version of SETI Live, available on most podcast platforms. So, do aliens speak physics and other questions about science and the nature of reality is a mind-bending exploration into what it would mean, scientifically and philosophically, for humans to communicate with an extraterrestrial intelligence through the language of physics. Particle physicist and co-author Daniel Whiteson joins me today to discuss surprising places he found ambiguity, what assumptions underlie science as we know it, and what our notion of physics might reveal or blind us to when grappling with alien intelligence. Thank you, Daniel, for being here today.
Thanks very much. So excited to talk to you about aliens.
Aliens, everybody's favorite topic around here. So your book comes out on November 4th. Congratulations.
Thank you.
Let's just start at the beginning. What motivated you to write this book? Was there a specific aha moment where you thought physics might not be fully universal?
Yeah, well, the thing that motivates me is I want to understand the universe. I'm a physicist because I couldn't not spend my life trying to unravel the nature of reality and energy and matter and time and space. To me, those things are so important and fascinating. And it's frustrating that we're making progress, but it's so slow. And, I'm a big reader of science fiction. And so I imagine the galaxy is filled with aliens out there, and those alien races might be much older than ours. And imagine what secrets they've uncovered. And there could be a civilization not too far away that's been doing science for 1,000,000 years, and they have the answers to all the questions we've been wondering about. And it's frustrating to think that the answers are there and they're known, and we just don't have them. They haven't shared them with us. And, folks like Carl Sagan, very inspiring, tells us that physics is interesting and unique and special among human sciences because it's like bigger than just Earth. It's bigger than humanity. That it's, alien planets have to follow the same laws of physics as we. And so he says that aliens will also discover the same laws of physics as we. So that's very tempting to believe that we're all part of some galactic science project, that we could work together to understand the nature of the universe. But it's also maybe too tempting and too flattering. And I started to wonder, is it a little bit of hubris to think that our physics, our ideas, our description of the universe is the only description? Or are we extrapolating from an example of one and assuming that the way we have come to understand the universe is the only way? It's the only path that aliens could take as well. And so the book is really an exercise in let's dig into those assumptions. Let's try to identify places where we've done something where we might have taken a different path, or we've made some philosophical assumption. Do we really have justification for that? It's not that I hope aliens are too alien that we can't talk science with them or use physics to talk to them. But I think it's important that we think skeptically about this stuff before the aliens arrive, so we're better prepared when they do.
Okay, so let's talk about these assumptions. Specifically, when you're talking about alien physics, what assumptions are built into our notion of physics that you think might not hold true for an alien intelligence? Are there any that really, when you kind of got into it, surprised you that might be the case?
Yeah, so I think there's a whole slew of them. And in the book, I try to organize into a few categories. Number one is do aliens wonder why? Do they do science at all? I mean, we're imagining meeting or hearing from some technological civilization. And it's very natural to assume, well, if they have technology like warp ships to arrive here, then surely they know how they work. And when they arrive here, we're going to be like, hey, explain to me, how do you build one of those? How does it work? What is the nature of quantum gravity, et cetera, et cetera? But that's an assumption. We don't know necessarily that aliens have to be scientific to be technological. And that sounds really weird, but that's the process here. We need to make sure that our assumptions are not just things that satisfy our intuition, that feel good, because the history of scientific discovery is tearing us away from our intuition, from the things we just assumed were true about the universe, and forcing us to accept the reality. And so, is it possible to develop technology without being scientific in the way that we are? Absolutely. We did it for many, many years. Like, look at stone tools in Africa. That's technology, right? People developed that without understanding at all what was going on. More recently, like beer and cheese and bread relies on microbes and how they feed and interact and grow. And people who used those technologies, who developed those technologies, did it through sort of blind trial and error without understanding what was going on underneath, but they did it, right? And even
Hmm.
metallurgy. So it's definitely possible to develop technology without science. And I think the science comes from a curiosity, a desire to understand the universe, to want to know how it works. And that's emotional, that's cultural, that might just be human. So it could be that there are aliens out there that it took them a lot longer because they're just sort of poking around randomly, but they developed super advanced technology without doing science. And when they show up and we're like, how does that work? They're like, what do you mean? Here's how you build one. Isn't that enough?
Yeah, here's a wheel. I know it rolls.
Yeah,
Um,
exactly. I mean, I
yeah,
cook in the kitchen. I'm not a fan of chemistry. I want to follow the recipe for the souffle. I don't really care how it works. I just want to eat the souffle, right? And so, it's certainly possible that aliens have a different relationship with these ideas than we do.
I definitely want to talk to you more about this notion of sort of reality and how we frame it. I'm going to welcome in some of our viewers though, because there's some really great locations going on here. Let's see. So I've got United Kingdom, New Hampshire. Let's see, Amsterdam, Belgium, Sweden, North Carolina. Thank you, Terrence Yakovas. You always ask such great questions. Another one watching from Belgium, Ron in Louisiana. Hello, Ron. Thank you for being here again. New York. Let's see, anything else? Brazil. Okay, wow. And Georgia. Wow. Okay, so global audience. Argentina. Yes, we're working on a definite global audience going here. Okay, so this being the case, let's talk a little bit about how we use physics sort of to define, frame our reality.
Hmm.
Is it sort of shaped by our human perception and cognition? How much of it do you think could turn out to be universal versus sort of our anthropic human perspective?
Hmm. Yeah, that's a great question. I think that our perceptions totally dictate the way that we think about the universe. We have these few senses, sight, sound, touch, etc., and we have the impression that they give us like a direct revelation of reality, that like what I see in the room around me is what my model of it in my brain is what's around me. But we already know that that's not true, right? There's a lot of things in the universe we don't see. We don't see ultraviolet light, but it's everywhere. Bees can see it. We don't see in the infrared. We don't see neutrinos. Most of the matter in the universe is dark matter, totally invisible to us. So the universe is not just what we see and smell and taste and touch. It's much, much more than that. And if you just look at the variations of perception here on Earth, there's an incredible variety. Birds sensing magnetic fields, fish sensing electric fields. It's really incredible. So that suggests that aliens could have a very different set of perceptions. And you might think, well, it doesn't really matter because we've developed ultraviolet telescopes and we can sense neutrinos and we can detect dark matter through gravity, etc. So why does it matter what our original biological perceptions were if we have technological extensions of them? Well, I think that our original perceptions determine how we think. They determine how we frame answers to questions, which is why we're always translating our new technological senses back into our original native ones. Like when we look at pictures from the James Webb Space Telescope, we don't look at them in the IR, we shift them to the visible. When we talk about gravitational waves, we don't describe them, we don't experience them, at least in terms of like ripples in space time. We translate them into sound because that's something we can understand. So I think it really shapes the way we think about the nature of the universe. And if aliens have very different kinds of senses, they could think very differently about the universe. For example, what if aliens are quantum mechanical and microscopic? And so to them, questions of like, what is a photon are not stuck in some weird middle ground between like a wave and a particle, neither of which perfectly capture the bizarre quantum nature of the photon. They have some intuitive sense for it. And so they've made much more progress along quantum mechanics. And there might be a challenge there in translating their intuitive quantum ideas into our intuition. Because in the end, physics is about translating the unfamiliar into the familiar. And if we have a different set of intuitive concepts and languages, there could be a real stumbling block there in making that connection.
That is, I wish I had, it's not often that my mind gets a little blown in these conversations, and it seems to be the writers who are doing a very good job of it. I love this idea that because of how we experience the world as humans, regardless of the science and technology around us, that still influences the science and technology around us.
Absolutely.
If birds who can, sense these magnetic fields and creatures who can see in infrared were to become technologically competent, how would their technology and how would their perception of the universe be different from ours? And I'm so blown away just trying to think about that. So thank you for that perspective. Let's kind of continue on where some of this might break down in trying to reach out to another civilization. One of the things in the book sort of seems to question whether or not math is inevitable, and you and I were talking before the show a little bit about how in my personal philosophy, I feel like math is a language in and of itself. Yeah. That we learn it starting at a young age by starting with numbers, by starting with basic formulas that make sentences that eventually you get conceptually to say, proving a theorem. And this becomes more paragraph. You end up, getting into calculus and all of these things. And it gets more and more complicated. And we don't necessarily teach it in that fashion. We kind of teach it very compartmentalized. Math is sort of math in and of itself. So that being said, in a very complicated manner, is math inevitable? Why might it not be a shared language with aliens?
Yeah, it's a fascinating question because math is really at the heart of our science. As you say, it's a language we use to express our science. And it's a common trope to assume that aliens have to do math because math is a fundamental part of the universe. I was recently watching the fun show Alien Earth, and they have an alien there like tapping out the digits of pi, and they make this connection. They're like, whoa, we connected with the alien, and that would be awesome. There's so many reasons why that might not happen. But there's so many reasons, first of all, to think that it might. Like, what are the arguments that aliens have to do math, or they have to have science that's founded on math? And the strongest argument is that math seems to lead the way in discoveries. Like, the pattern of physics is mathematicians have played around with something they thought were cool just because they like nerds about numbers and it's awesome for them. And they don't care about the implications and is this going to be useful? They're just like, look at these cool patterns. We developed this fun game. Yay. And I love that. And then like 100 years later, some physicist is like, oh, thanks for developing all this infrastructure. We're actually going to use it to solve this problem over here. Like people developed groups and rings and abstract algebra just because they thought it was fun. And then 100 years later, we discovered, oh, group theory is essential to understanding the nature of particles at the fundamental level, and the way they interact reflects like how things transform through a group. It's a deep, deep insight. And the math was there first. And there's times in the history of physics where the math has directly led us to discoveries, like even before quantum mechanics. Maxwell, for example, he's looking at the equations of electricity and magnetism. He wants symmetry. He wants beautiful mathematical symmetry. And he notices a term is missing. It would be so much more symmetric if that term was there. The math leads him to discover displacement current, which is real in the universe. So there's so many times when you feel like, wow, math must be the language of the universe. Personally, I remember as a junior taking quantum mechanics, seeing those calculations where they calculate a number to 10 digits and then they do the experiment and it agrees. And I had this moment of insight, which was almost spiritual, where I felt like, wow, this is not just a description of the universe. This is the source code. This is how the universe calculates it because it's so accurate, right? Mm-hmm. So that's very compelling. And it suggests that like math is something fundamental. But on the other hand, we always have to wonder, like, is that just because of the way we're seeing it? Are we seeing it through a single kind of lens? Can we, if we could step back and look at it through another lens, will we also have to use math and see things the same way? And there's surprisingly compelling arguments on the other side. There's a guy named Hartree Field who did the exercise of saying, well, what if we stripped away numbers from science? Could we do science without any numbers at all? And your first inclination is like, dude, what are you smoking and where can I get some of it? Because it sounds crazy, right?
Yeah.
But he points out that there's a lot of the mathematical machinery in our science that isn't necessarily necessary. For example, fields. Maxwell and other folks' great invention to simplify our calculations is this idea that you can put numbers in space. We call those fields. Electromagnetic fields are just like vectors in space. But we don't see those fields directly. We see their effect on particles or on objects, but nobody can ever directly interact with the field and say, here, the field is real, I know it. It could just be a construct, an intermediate step in our calculation that's useful for us. So he went through the exercise of developing a gravitational theory with no fields and no numbers at all. He keeps things like relations, this is bigger, this is closer, this is smaller. But that philosophical step of assigning things to a number line, he never does it. And he develops a theory and it works. So it's sort of a proof of principle. Now, his theory is really ugly and really hard to use and really counterintuitive. But it makes the point that maybe math is not necessary. Maybe it's just really, really useful. It's very handy for our kinds of calculations, but maybe the aliens have come up with a different useful shorthand for their kinds of calculations so that they're doing science without any math. And if you ask the philosophers, they don't even really know where a lot of our math comes from. They dig into the foundations of math, but it's a bit of a mess down there. Gödel shows us that you can't even prove everything that's true in math, starting from the basic assumptions. So there's a lot to wonder about whether aliens will have to use math to express their science.
This kind of leads me right into the next question that I had, which are there concepts in physics that we treat as obvious, like using numbers, like cause and effect, things like this, that you look at and say, these are specifically human-centric?
Absolutely. And you put your finger on, I think, the strongest one, which is cause and effect. This concept of causality, which is closely linked to the concept of locality. When we build our theories of physics, we start from some assumptions. And those assumptions seem totally intuitive to us, like, causes happen before effects. Makes a lot of sense. Who could object? Or similarly, locality, that a cause has to be near the effect. You can't be like instantly killed by some alien in Andromeda galaxy by pointing a death ray at you, because things take time to propagate through the universe. You have like a sphere of influence which grows. And these things are at the heart of our construction of modern physics and quantum field theory. But how do we know that they're real, that they're actually required in the universe? And there's a new class of theories that are being developed that question these things. Maybe causality and locality aren't fundamental to the universe. Maybe they're just sort of emergent, they're approximate, the way sort of like mass, conservation of mass was kind of approximately true when you're just doing chemistry. But then when you go down to the fundamental physics, like, it's not at all true. And so it could be that some things we assume at the foundations of physics are blinding us to other opportunities. And that's one reason I was excited to write this book, is if we can open our minds a little bit to the foundational assumptions and rework them and explore them, maybe make other choices, we could find new directions to do physics. So it might not even be required for the aliens to come to blow our minds. We could sort of be our own aliens by trying to rethink some foundational assumptions and maybe make some discoveries, but that's very speculative.
It sort of reminds me, over the summer, one of the things that I did with our REU students, we had undergraduates who are doing research here. And one of the things that was really fun was we went out to the beach near Monterey. Not at Monterey, we were a bit further north, but my group had to look at the world as aliens having landed on Earth. And, they don't know really anything about the planet. And so it was really getting the students to sort of look at things in a very, very fundamental way. Like, they're looking at the birds and like, oh, look, birds. And I said, but you
Mhm.
don't know they're birds. You don't know why they're doing that. You don't know what they're doing. And, that really helped them reframe. I actually ended up staring at, I hate to say this, spiders building webs in bushes. I do not like spiders. I am deeply arachnophobic, but I'm like, this could be a civilization right here. We don't know. We're so much bigger than they are.
Yeah.
Perhaps there is some very complicated communication going on here, and
Mhm.
they have communicated how they want to
Mhm.
design this structure. And it was a really fun exercise in sort of changing how you look at what we say we know. And I think that really helps a lot of scientists sort of break out of these basics. Like we always say first principles. How first principles do you think everybody sees the world?
Yeah, it's a good question. And I think a lot of that will be shaped by the things they're curious about and where their science leads them. We tend to think like that aliens will be interested in the same kinds of things that we are, spiders or not spiders, but like zooming out more like planets, right?
Mhm.
We say, okay, we have planets. Kepler found the laws of motion. Surely aliens will also investigate the same things and they'll write it in other squiggly forms, but they'll figure out, Kepler's laws of planetary dynamics and eventually Newtonian physics, etc. But the fact that we focus on planets is because we live on a planet. And so we think of planets as important. Think about every representation we have ever made of the solar system. Is the Earth to scale? None of the planets are to scale. We like zoom them out massively, blow them up because they're important to us. And
Mhm.
these days, we don't even have a great definition of like what a planet is. We're sort of stuck in this awkward corner where we want so badly for planets to be a thing, but in reality, the solar system is just kind of like filled with lots of chunks of stuff, from tiny dust all the way up to gas giants and stars. And our attempt to categorize them is like historical and awkward, and really just like the way humans draw dotted lines around stuff. So we have chosen to focus on planets because we live on one. But
Mhm.
imagine you're an alien that's like in the atmosphere of a star. You're like a plasma being. You don't care about the planets. The planets are like a little crumb, a little detail, right, in the solar system. It's all about the star, man. And so they could go down very different roads. And not just like, they don't discover this, but they could just be interested in different things. And the theories that they develop could be answering their questions and rather than answering the kind of questions we're asking. And so if you have a fantasy that aliens are going to show up and like deliver us answers to our questions, they might show up and have other answers. And we're like, Jan, who cares about that? We want to know about this. Right. And so I think there's a lot of culture in the questions that we ask about our science. And it's hard for us to zoom out and to recognize that because we only have this one example of our science, human science.
I like that. It's sort of this idea that we might be blind to some of our biases. I mean, absolutely 100% makes
Yeah.
sense. You don't know you're biased until someone points it out. But what sort of are there physical phenomena? I mean, obviously there probably are, simply because, as you said, we can't see fields.
Mhm.
We can't see. We don't have the capability of seeing infrared or anything outside as we've named it, the visible spectrum. I mean, right there,
Yeah.
there's a human-centric bias.
Mhm.
So are there any other physical phenomena that we ignore or that we seem to be blind to simply because our biology has filtered them out, but an alien might look at it and be like, no, that how come you don't know that?
Absolutely. And it's hard to know in advance, right? It depends on what the aliens are like and what they're interested in. In the book, we talk about all these sort of highbrow concepts, the fundamental assumptions, et cetera. But I also wanted to make it kind of concrete and to give examples. And so
Mhm.
there's a bunch of very brief fictional snippets about what first contact might be like in some scenario. And so, I'll give one example of aliens that have evolved to eat energy from neutrinos. We drink light from the sun, or plants drink light from the sun, and then we eat the plants. Our whole ecosystem is based on photosynthesis, essentially.
Right.
But what if there are aliens that somehow manage to capture the enormous flux of neutrinos? Because, the sun puts out a lot of energy and it puts out zillions and zillions of neutrinos, which carry a lot of energy as well. So you can imagine potentially like aliens that evolve in the dark under a frozen ocean. They can't see photons, but neutrinos can penetrate. If they develop like the ability to gobble energy from neutrinos, neutrino synthesis, they would see the universe very differently. And they would evolve very differently, and they might not be interested in a photon based life form at all. So it's just fun to think about the various ways aliens could be, and I think it's important to think broadly, as you were saying. And some people argue on the other side, well, look, there's got to be some things we have in common. Like, what if we say, forget planets or forget atmospheres? What if we zoom down to the smallest bits in the universe? Wouldn't we have those in common? And that's very tempting. And as a particle physicist, I'd like to believe that. But our current theory of physics, where we describe quarks and leptons and bosons and all sorts of stuff, it's a triumph, but we also know it's not the reality. It's our description of the universe. It's not a description of the fundamental nature of the universe. We know it's an approximation. We know that these things are made of some smaller bits. It has a relationship to the true theory that like Newton's theory has to Einstein. We know it's like true in some cases, but not always. It's at best a very good approximation. And that turns out to be true for all of human science. There is no science that we have that we could say, look, this is the truth of the universe. Everything we do is an approximation, which means that aliens, if they make different approximations, could end up with a very different description of the same set of phenomena.
Absolutely. That, again, still mind blown. I'm going to welcome in some more viewers, and then I want to talk a little bit more about aliens and how we communicate with them. Let's see. We have people watching from Canada, in Ontario. Thank you. Australia, Poland, Pennsylvania. I thought I saw one more in here. New Jersey and Germany. So again, thank you so much for watching all over the world. I mean, that is a lot of people watching from different places. So thank you everybody for being here. Oh, and one from London. So
nice to meet all of you. Hello.
Yeah, thank you everybody for tuning in. So Daniel, the whole point, the purpose here was that, you're questioning how we communicate with aliens, should we find them. So let's move out of talking about physics and talk about how this affects the communication side of things. So say we wanted to send a message or decode a message, what core ideas do you think would be the safest bet for mutual understanding, and which ones do you think would be really risky?
Yeah, this is such a great question, especially at SETI, right? And let me start out by saying I'm a big fan of SETI as a project, totally support it. Wish we did it 100 times as much as we do, more telescopes, more listening, all of that stuff. Big fan. However, the more I read like the theory of linguistics and philosophy of communication, the more I'm down on the possibility that we could ever make contact and understand each other without being in the same room, just like via communications. And, we don't have to be theoretical about it. We can look at like what humanity has tried. For example, Carl Sagan and Frank Drake and those folks put together an attempt to talk to potential extraterrestrials on the Pioneer probe, where they designed this plaque where they had to solve exactly your question. They're like, look, aliens might see this. What do you say on it? And to their defense, I think they were only given 2 weeks to put this together. So it was a bit of a rush job. And they did their best. They describe, if you haven't seen it recently, it describes like the hydrogen atom. You have the proton in the middle and the electron going around. And it shows how the spin of that electron flips. And they use that to define a constant of time. So they definitely understood that you can just like use English or even use our mathematical symbols, because of course those are earthbound. And they tried to come up with symbols that they thought would be intuitive, would inspire in an alien brain the same ideas that were in their brains. The problem is, if you talk to theorists of symbology and linguistics, that step where you encode your ideas into symbols is always cultural and arbitrary. Like those symbols made sense to them because of who they were and what they understood. It doesn't necessarily make sense to aliens and even to other humans. I actually did an experiment where I took the Pioneer plaque and I showed it to a bunch of grad students here at UC Irvine. And
Hmm.
these folks are young enough that they'd never seen it before. And I asked them, I
Sure.
said, interpret this. And they sat there for 2 hours with donuts and coffee, and they made no progress at all. Like, they were creative and they came up with hilarious interpretations, but none of them were on the right track. And like, that's maybe the best possible audience. These are like humans, the same brains, obviously, same culture. These are physics grad students. And so the possibility that aliens could decode that they instinctively look at this depiction of the hydrogen atom and go, oh, yeah, he's talking about hydrogen, I think it's very unlikely. And I think going beyond that, if we got a message from aliens, the chances that we would be able to successfully decode it seem really remote without them here to help us, without them here to like point at stuff and say, like, this is an apple, this is a rock, this is two apples, or whatever. Just having the message, I think we are really struggled because we have no idea what they've used to encode it. And number two, even if we do decode it somehow magically, we wouldn't know when we got it right because the alien ideas could be so alien. We're like, well, is this correct? Like, when you get a message and it's scrambled in English, you know when you figured it out because if you found the right key, boom, it snaps into something that makes sense. But
Right.
this is supposed to boom, snap into, oh, alien something. Who knows if it's right or wrong? And so I think, frankly, it's going to be really, really hard to ever decode alien languages because there's that arbitrary translation from the idea to the encoding. On the other hand, maybe the aliens have telepathy, right? Maybe the aliens have evolved a way to communicate brain to brain, so they don't even use symbols and they don't even communicate. So who knows? But I think it's going to be challenging, which is why in the book, I'm mostly focused on the scenario of the aliens have arrived here on Earth, because then we have a context in common. We can point at stuff and name it, and that doesn't always
Hmm.
work, but it's a huge leg up over just like, hey, we got a message. Who knows what it means?
That's a great trope in a lot of science fiction, right? And even
Mhm.
some non-science fiction writing, where you meet the civilization that doesn't speak the same language, and you spend all this time like pointing at things, like this is dirt, and this is me, this is my name, and trying
Right.
to get someone to understand, and figure out an entire language that way. So I think that's a very valid way to look at it and say, like, we really, it's it's not going to happen like in Contact, right? We're not
Yeah.
going to get some message that we can somehow find the key to and translate to a point where we're like, oh, we need to build a thing. So
We all want that to happen, right? That's everybody's
yes.
fantasy. And that's the reason I think we need to be careful, is that the fantasy is tempting. And so it's tempting to just believe and be like, oh, that's what it's going to be like. It'll be so great, right? But reality is never like your fantasy. And especially the things that you want to believe are the things that you should dig into and wonder if they're true.
Oh, I want to talk to you for like 2 more hours, and I know the audience is absolutely fascinated. I'm going to try and get to a couple questions because we have gone past our half an hour. I apologize, everybody. Let's see, what have we got? Uh, yeah, here's a basic question, and I think this is like straight at the beginning of it.
Mhm.
We like to think that 1 + 1 = 2 is a
Yeah.
constant, but could other intelligent beings disagree with that?
Great question, John. Love it. And in fact, I had the opportunity to ask Noam Chomsky how he would talk to aliens, because like he's a super smart guy who's thought about language. What does he think? And he agreed with you. He's like, look, we should start with arithmetic. 1 + 1 = 2, and build from there. And there's a powerful argument there because it turns out all of math is built on arithmetic. When they were trying to figure out like what is the foundation of math, they discovered that at the heart of it is arithmetic, and from there you can derive everything. However, how do we know that aliens will think 1 + 1 = 2? It turns out there's also a lot of culture there in like deciding how numbers work. If you look at like a set of mountains, and you count how many mountains are there, you might count one, but somebody else might be like, no, there's another peak there. I call that another mountain. There's like an arbitrary decision there where you decide this is one or this is two. And that turns out to be a little bit cultural. Or like if you look at a bunch of apples on a table and say, how many are there? You might say, well, these are all apples, so I'm going to call them 6. And somebody else might be like, no, no, no. Red apples and green apples are very different things. There's 4 reds and 2 greens, right? So this designation where you separate things into countable objects turns out to be kind of cultural. And even on Earth, Like, it turns out Japanese as a language has a very different approach to like countable objects than English does. You can read all about it in the book if you're curious. And so, it's not hard to imagine another scenario. Like, go back to my atmospheric plasma aliens. What if you don't have such a distinct boundary between yourself and other individuals in your race? You sort of flow and combine and merge and split constantly. Then the concept of being countable, being one thing and not another thing, or two things, might never come up. So aliens might not come to 1 + 1 = 2. They might just start with real numbers, and go from there. So it's not guaranteed that integers have to be a foundation to alien mathematics, if they even do math.
This leads into a question from another viewer, a regular viewer of the show. Hello, Omnipotent Media. He notes, as you mentioned, Japanese, maybe Chinese letters is closer than our letters. Symbols would make more sense, and they could mean full paragraphs are meant for one symbol. So this is kind of the same thing that you're talking about.
Yeah.
There might not be this physical breakdown, and these larger pieces are what they speak in.
Yeah, it's a great idea. And, it's sort of sobering to look at the history of trying to decode ancient languages. I did a deep dive on this for the book. We can't decode alien language because we haven't gotten any examples yet. But let's do the easier thing of trying to figure out how hard is it to decode other human languages from like ancient civilizations that are no longer around to explain it to us. And we don't have a great track record. And sometimes it's because we're making these assumptions, just like this listener asks, how do you organize this? How do you interpret this? How do you map our language to this language? Like, think about the Rosetta Stone example in Egyptian hieroglyphics. That's often seen as like a huge success, right? But actually, we took us 20 years after we had the Rosetta Stone to figure out what the pattern was, even though we had like a translated example. We couldn't make the connection. And the reason is that we started from the wrong assumption. We assumed that hieroglyphics were pictograms, that if there's like a little bird in there, it's something about birds. And if there's a little bit of water in there, it's about water. It turns out they're not. They're actually sounds. They're phonetic, just the way our language was. So we made an incorrect cultural assumption, and it led us down the wrong path. And it wasn't until we got a cheat sheet that we were corrected. And are we going to have a Rosetta Stone with aliens? Almost certainly not. And even if they do, we might still not figure it out. I mean, it's going to be much, much harder than Egyptian hieroglyphics. And there are lots of examples of human languages that have never been decoded. These are other biological humans with a very similar culture to us, and we just can't grok it. We can't what are they talking about? A great example of the Etruscans, which lived near the Romans, and the Romans wrote about them. We know a lot about them. We have lots of examples of their writing. Nobody's ever cracked it. So yeah, that's the kind of thing that makes me pessimistic about the chances of decoding aliens. And the listener is exactly right. You need to think broadly about the way alien languages might work, because it could be very different from ours.
That's very true. I've always been sort of fascinated by the whole concept of the Rosetta Stone, that someone thought to put down these three things to sort of, translate them. That someone thought this, in this sort of manner, like, we need a primer for this, I'm like, well, thank
glad
you.
they did.
So, glad that they did. We've learned a ton. In fact, I'm reading someone else's book called Our Moon, and there's a lot of history of moon worship in it that actually goes back to Babylonians and things that we have learned because of the Rosetta Stone. So, these sort of translation techniques are great. And I think they're very helpful, but you have to know they exist. You have to have someone who thought ahead in this manner. One of the things that we do here at the SETI Institute, of course, is Lawrence Doyle works on whales, right? Communicating with whales, understanding whales, and had a very small breakthrough in that it seemed that they carried on a 15-minute conversation with a whale.
Wow.
But here's where we're looking at what is tantamount to an alien species on our own planet, and trying to understand how they communicate, because we know they do. We just don't understand the context. Again, we don't have the same biological perspective on things. So exactly. It is such an in-depth topic to sort of dig into. So thank you for taking the time to write this book, to dig into this. I think this is kind of one of those ultimate rabbit holes to fall into. So thank you for putting that out there. Just to finish things up, because we are way over, what's your favorite what if from the book? A thought experiment that is still keeping you up at night?
The thing that haunts me the most is, what if we're super duper lucky and the aliens, we can communicate with them and they do science and it's mathematical and they're curious about the same things as we are and have all the answers, like best case scenario, but we aren't smart enough to understand it. What if they explain it to all us and we go, huh, I don't get it. And we just like, the fruits, the jewels of the universe are being tossed to us and we just can't grab them because there's no guarantee that the universe is understandable to humans, right? So far, it has been possible, but we don't really know why the human brain is capable of understanding like 12-dimensional manifolds and all this complicated math, which wasn't necessary to survive, thousands of years ago. So that really haunts me, this scenario where my fantasy comes true, but we just can't understand what they're telling us. Oh, what a tragedy.
I mean, any physics student has had that topic in physics that just eludes them. Mine is E&M, electricity and magnetism, because I'm very much a visual person. I'm an astronomer. I'm a planetary scientist. I can't see electricity. I can't see magnetism. Fields make zero sense to me.
Right.
So for me, that was definitely like a struggle. So I could imagine, having a civilization come down and go like, here's the answers to life, the universe, and everything. Oh, no, you don't get it. Okay, well, that was a waste of our time. And just that, now I'm going to be up all night thinking about that. So thanks.
Better that than spiders.
It's true, actually, although this feels a little more existential than spiders. But yeah. All right, everybody, thank you so much for joining us today. Thank you, Daniel, for being here. His new book, Do Aliens Speak Physics, will be out in bookstores and online on November 4th. You can learn more at the link in our show notes. We do link to Daniel's page on it, so you can see some of the blurbs and descriptions, and grab a copy of that. And also, everyone, as always, if you enjoyed this conversation, please like it, share it with your fellow SETI nerds, subscribe on YouTube for more space science interviews like this one. And next week, I will be joined by 2 scientists to talk about how Uranus's moon Ariel may have had a subsurface ocean in the distant past. So stay tuned and get your Uranus jokes all ready, because I know you're all sitting on them. So look, I made one to start. All right. And as always, we are a 501c3 nonprofit. So if you want to go to our website and throw some extra money at us, it would be very helpful to keep this program up and running. As always, we thank you for your bits, your subs, your super chats, your stars, all of those things on our social media channels. Help keep us doing these shows every week. And make sure you subscribe to our newsletter. That way you get our news straight into your inbox just once a week. We're not going to overwhelm you. So you can find that on our website as well. And Daniel, thank you again for being here. Thank you
My
so
pleasure.
much.
Wonderful conversation. Thank you. And thank you to all the listeners.
And good luck on the book. I hope that the release goes well for you.
Thank you very much.
Until next time, everyone, keep looking up and stay curious.